The rank.EQ function returns the rank of a value within a specified list of values. The rank.EQ function consists of three parameters. The first is the number whose rank you want to find. In column C, we want to display the rank of the sales values in column B. The number parameter will be B2. When the function gets copied down through the column, the cell address will automatically adjust. The reference parameter is the list of numbers to be ranked. In this example, that is the sales values. The last parameter, order, is optional. If you enter a 0, the rank will be in descending order, which is the default. I will enter a 0, but it is not required. I will double-click on the autofill handle to copy the formula down through the column. Row 10 has the highest sales value, so it is ranked number 1. If two or more values are equal, they receive the same rank, and the next rank is skipped. 3 rows have a value of 600. They share a rank of 3, and because of this, there is no rank for 4 and 5. 2 rows have a value of 500. The two share a rank of 6. Because of this, there is no rank of 7. To make the functions easier to use and understand, I will assign the name sales to the sales value. The only difference needed for changing the rank to ascending is to change the order parameter to a 1. Notice that the sales of 800 had a rank of 1 when using descending, and a rank of 10 when using ascending. Rank average uses the same parameters as rank.EQ. With rank average, when there is more than one value with the same rank, the average of those ranks is returned. I will enter the 0 for descending. The two sales values of 500 would have a rank of 6 and 7, so they have been averaged to 6.5. The three values of 600, which would have a rank of 4, 5, and 6, average out to 4. I will enter 1 for ascending. To make the functions easier to understand, I will assign the column headings to names for our data. We can compute rankings within groups. In this example, we want to rank our sales within regions. To do this, we will use the COUNTIFs function. We will use region for our first criteria range and cell B2 for our first criteria. We will assign sales to the second criteria range. We need to test if each cell going down this column is greater than or equal to the value of that particular region. If you want to add grouping within an additional group, just add an additional criteria range and criteria. This function is identical to the previous one, except we are adding division for the second criteria range and cell C2 for the second criteria. You can use any icon symbols to represent ranking values. Here, I have created 5 symbols for the first 5 rankings. The other rankings will use the last symbol in the list. On this worksheet, we will first determine the ranking for the previous month's sales, and then find the amount of rank change between the current and previous month's sales. Before we do that, I will get the area names for some of our columns. I will get the ranking for our previous month's sales by using the RANK.EQ function. Since I want to view the ranks in descending order, I will ignore the optional order parameter. To get the change in rank, I will subtract the previous month rank from the current rank. You can see that in row 2, the $100,000 of sales would have a rank of 1. The previous month's sales of $92,000 had a rank of 3. Therefore, Alice's sales rank improved by 2 ranks. I will double-click on the autofill handles to copy the formula down. We can combine multiple functions to determine ranks over a 3-month rolling average. Looking at the first 3 months, you can see that the ranks appear as they normally would for descending order. Now, let's look at the second set of 3 numbers. 65,000 is the lowest value of the 3, so it has a rank of 3. Looking at the next set of 3 values, you can see that 80,000 is the second highest value. In the next group, 55,000 is the lowest value, so it is assigned a value of 3. Looking at the last set of 3 values, 92,000 is the highest value and therefore has a rank of 1.